Welcome to the online lecture series of CYBOSIUM. I'm thrilled to be here with you all today as we embark on a journey of discovery and learning. UAS, Unmanned Aerial Systems, Autonomy, of utmost relevance in today's world because of its potential to revolutionize various industries such as transportation, logistics, agriculture, and defense. Autonomous drones can operate with high efficiency and safety, reducing human errors and providing new capabilities for data collection, surveillance, and delivery. And it's my greatest pleasure to introduce our esteemed speaker for this session, Ms. Shefali Saxena. She is currently working as a flight control development engineer at Airbus and is a true expert in this field with years of experience and a wealth of knowledge to share. Her passion for aerospace sciences is evident in her work, and she has been instrumental in advancing our understanding of UAS autonomy. She completed her BTech in Aerospace Engineering from Indian Institute of Space stage of developing a 6DOF simulation, gray box modeling, estimating almost 5 years in the field of control systems. So without further ado, let's get started. Over to you, ma'am.
Hi, good evening, everyone. Thanks for a very decent introduction, Anna. Yes, so as Anna has introduced, my name is Shefali Saxena. Yeah, after my BTech in Aerospace Engineering, I joined Tata Advanced Systems Limited, where I have worked for 3 years, mainly specifically in unmanned aerial vehicle domain. And it's my pleasure today to give a lecture to you guys. So we will try to make it as an interactive session. So as and when you have any doubt, or even if you want to converse something, you can unmute yourself and speak out, or you can type anything on the chat, or like you can raise your hands. So it's like, don't make it so strict, as in questions and answer session can be in between as well. So I'll just share my screen. Let me know once it is visible. Is it visible now? Hello? Hello?
Yes, ma'am.
Okay, fine. Okay. Thanks for the response. Yes. So basically, today's agenda is we'll start with an introduction, and then we'll go through a brief history of unmanned aerial vehicles. Then, since the topic is about UAS autonomy, I would like to describe the different levels of UAS autonomy to all of you guys. Then we'll go through types of UAV. And again, every UAV has a different working principle. So we'll discuss a bit about it. Then whatever parts are there inside UAV, such as color, sensor, motor, ESC, and all, we'll discuss in detail about it. Then we'll come to communication protocol, wherein we will discuss about data link and all those things. And then obviously, since it is a conference happening in India, so let's look into the India's drone industry and what advancement we have made so far. And then after going through applications of UAV, I would like you to introduce some of my projects, which I have done during the course of 5 years of my experience. So a deep dive into it. And yeah, so that is the agenda for today. Hope it looks good and you guys are excited for it. Yeah. So as I said, you can stop me or you can ask questions or anything is okay with me. Okay, so as all of you know, basically we are discussing first about unmanned aerial system. So it refers to both UAV, individual or group, responsible for flight control ground. And then so there is a flight control station, as you can see in the picture. This is our ground control and this is our UAV. But for communication between UAV to ground control station, there are so many sensors which plays into role. So there, and again, if it is not an autonomous UAV, we need pilot's input, which will come via joystick. And if there is a camera on the UAV, we'll get the video feed from the UAV. And then again, the GPS signal to estimate the position of UAV across the globe. So this whole system combines is called as a unmanned aerial system. So alone UAV is a vehicle, but if we combine UAV with ground control station and all of the components which defines the location or which defines the UAV working is basically comes under UAS. So if I go into a theoretical basis, so basically UAV is defined as powered aerial vehicle that does not carry a human operator. It uses aerodynamics forces to provide a lift and can fly autonomously or be piloted remotely. So yeah, you either a pilot can control it or it has a flight control system, like it brains inside it, and then it can go along with that flight control system as well. So, and then whatever flight it needs to follow, it can be predefined or it can be controlled by a pilot autonomously, by computer or by joystick if pilot is controlling it. So this whole system is UAS for us. Yeah, if we look into the history of UAV, so the first powered UAV was AM Law's aerial target, which is shown over here. So that has been made in 1916. So the technology is that old. Um, Has anybody unmuted themselves? I just heard some noise. Okay, I'll take it as a no. Yeah, okay. So 1916 was the first year when all UAV was introduced and all UAV technology has started working upon. Then since 1935 till 1951, during the World War II times, there were several attempts which were made for UAV production, because we knew that people needed bombardier aircrafts and all. And if there is no human life involved, then it is a greatest advancement for a country. So there were many technological changes which has been integrated for this unmanned aerial vehicle advancement. Then finally in 1951, the first jet-powered UAV, which is shown here, named as Teledyne RAN Firebee-1 was unveiled. And it was totally remotely controlled. So that was the biggest achievement for our drone industry. And then finally in 1959, the US Air Force launches its UAV development program named Red Wagon. So this was the era, I would say, between 1950 to 1960, where the fastest advancement of UAV has been introduced. And since we have been following upon it, many countries are working upon it. So obviously, USA and Israel are very much technological advancement in this field. So they have been coming up with latest technology, different design, manufacturing process, and all. Even India is also wrapping up the process after 2020, and there are many laws and regulations coming into picture. So which is like great news for us. And then in 1980s, Israel also came into picture and they developed their modern UAV, which was actually used in real-time surveillance. So that was a like very big achievement during that time. And finally, in 1986, AI Corporation introduces UAV, which is purchased and used by the Department of Defense. So yeah, this was the era, and then now we'll come back and then we'll talk about what is happening in today's generation. So yeah, so like while along, I'll just give you some interesting facts about UAV. It can be a bit away from the topics, but the facts are like very less known. So maybe like it might be interest you guys. So yeah, talking about it. So the first interesting fact, which I feel like it's quite interesting, is armed drones were originally invented to find Osama bin Laden back in 1998. So like 1998 was the time which was way before 9/11 attack. So like if you guys can imagine, if they would have succeeded in this task, then we would have never seen 9/11 tragedy which happened. So yeah, the attempts were maybe not that severe, and we were so early in the technology. So like it was not they were not successful in developing into it, but there were serious attempts which made for that. And yeah, yeah, as I said before, 9/11 attempts have has been happened. Um, and US Army were already discussing plans to use drones in order to track down and trace the movements of Al Qaeda in the Middle East. So yeah, so way before 2000, this was happening. Okay, now let's discuss about applications of our unmanned aerial vehicles. So there are many sectors, as in commercial, civilian, government, and military. So we'll take each topic and discuss in details later, but I'll just give you a platform to think about it, think about the applications as of now. So if we look into commercial, it can be used in remote sensing, then resource exploration or surveillance are the main task. And for government purposes, it can be used for search and rescue mission, forest fire detection, scientific research, or extreme climate condition. And now in scientific research, it is being used in agricultural advancement as well. So which is a great use. And again, domestic policing and all. And for military, surveillance is the main thing. And basically the tragedies which happen like tsunami and all those things where human cannot directly go. So drones play a major role by supplying food and other things, deliveries of other goods and armed attacks. So drones have been used like one armed uh, a drone is there is already exists, and as I have described earlier, in 1998 they were trying to make a armed drone for killing Osama bin Laden. So the technology is still ongoing. There is no proven facts that it's been happening, but yeah, you might have heard in the recent news that there have been many attacks using drones in by Israel to in other countries. So yeah, the technology is taking place nowadays. So since we are talking about autonomy, let's discuss about levels of drone autonomy. So there are levels defined from level 0 to level 5. So totally there are 6 levels of autonomy. Level 0 means there is no autonomy. That means pilot has the full control 100% of the time. There's no brain inside a drone or inside a fixed wing or inside an aircraft. Pilot is there, which is remotely controlling the aircraft totally. Whatever pilot commands have been taken place, those can be again seen in the UAV. So UAV will behave accordingly. And in level 5 autonomy, it is fully autonomous. There is no need of any human intervention. So basically a flight path will be set and UAV will be following it, and there will be multiple sensors associated with it, which will detect obstacle, avoid the obstacle, define its own navigation and guidance path. So one by one, step by step, we'll go into each level, what each level indicates, and where are we in the present scenario. I hope I'm clear till now. Is anybody is having any questions? Okay, I'll just go ahead. I'll take it as a no. Yeah. So as I have described, level 0 means no option. So the pilot is in full control of every movement, 100% manually all the time. So the major application of this autonomy level is racing. So like car racing, which we see F1 races and all, there is a drone racing competition happening. So which purely depends on the pilot's skill. There will be many obstacles in between which pilots need to overcome by its own experience and all, and then the racing competition will go on. So there are actually people participating in it. So pilots get trained on drones first and then participate in the racing competition, just like we see other gaming challenge or racing challenge via cars and all, F1 formula racing and all those. So next level is level 1, which is called as pilot assistance. So basically here, the pilot remains in control of the overall operation and safety of the vehicle. However, the drone can take over at least one vital function for a finite period of time. It has no sustained vehicle control and is never in control of both speed and direction of flight at the same time, but it can provide support for navigation or keep altitude and position. So it's just that level in the level 1, they have given an advancement to the drone saying ki it can either control the altitude or it can either hold the speed. So it can be used in inspection. Suppose we have to inspect one area, so we can just guide the UAV. First, pilot can take control, reach to that particular location, and then we can tell the UAV, okay, now you are here, inspect the area. So basically, it is holding that altitude and hovering around the place. Or if we want to trace some moving target, so once target is locked, drone can actually follow the target with a particular speed. Okay, so basically here pilot has full authority, but drone can maintain altitude, that means height, above ground level height, or it can maintain position or speed. So one of the things drone can do once the mode is engaged, like in the car or bike, we have cruise mode, right? Where vehicle will be driven at a particular speed. So here we can have altitude hold mode. So drone can hold that altitude and then hover around that altitude. But pilot can like switch on the mode or switch off the mode and take over the control. Then there is level 2, which is called as partial automation. So basically, here I have taken a screenshot from a mission planner computer where we set the flight path for the UAV. So like I mentioned, right, there's a ground control with us. So we have to use that control station where all those software which communicates to the UAV are mentioned. So once we set the path, this will be fed into the UAV. So basically, in level 2, the pilot is still responsible for the safe operation of the vehicle and must be ready to take control of the drone if something happens. However, under certain conditions, the drone is able to take over control in terms of heading, altitude, or speed. So the pilot is still fully in charge, including monitoring the airspace, flight conditions, etc. But and like in present scenario, most manufacturer companies are building drone at this level, at level 2. So here, the platform can assist with navigation functions and allow the pilot to disengage from some of their tasks. So basically, a pre-programmed flight path is uploaded, something of that sort. This flight path is uploaded to the drone, and drone will start executing the task to fly along these transact after takeoff. So as soon as we take off, pilot will take off. Since the path is there with drone, so these are called waypoint. Like this number 1 is a waypoint, number 2 is a waypoint. So all these are called as a waypoint. And this is the home location where drone is taking off, from where drone is taking off. So from home location, once pilot reaches to the position 1, drone will activate, the mode will activate, and drone knows now where to go next. It has to follow the path. Okay, but it cannot detect any obstacle. There is no sensor for detecting obstacle. If there is some obstacle comes in on the way, drone doesn't know how to behave, or it doesn't even know whether there is an obstacle or not. There is no way, because since there is no particular sensor to detect it. So in level 0, no control. In level 1, drone can maintain altitude or a position. In level 2, we can give a flight path and drone can follow it blindly. So now comes the level 3, which is conditional automation. So like at level 2, the drone can fly itself, but the human pilot must still pay attention and be prepared to take over at any time. So here the drone notifies the pilot if intervention is needed. So there is a pilot is basically the fallback system. If there is some mistake, pilot has to come into picture. Basically here there are particular sensors which detect the obstacle. If there is some obstacle in the way, obviously it has flight path angle and it is following all those flight path. But maybe some lidar or radar sensors are which can actually detect the obstacle. They can detect it, but they do not know what to behave or what to do next. So they'll just trigger, as soon as there is some obstacle, they'll trigger one alarm to the pilot saying there is an obstacle and you have to take control. And so pilot will just take control and come out of the way. So it will just change the flight path, and again it can engage the mode, and drone can follow it. So in level 3, there is an advancement that at least our drone will not get damaged if there is some obstacle on the way. So here, yeah, as mentioned, obstacle detection is done by drone. Pilot takes over in case of obstacle detection, and then pilot comes out of the obstacle. This is also being used for mapping, surveying, and delivery. So if it is being used as a delivery drone, then pilot has to look into it always, because drone is going to send an alarm when it detects an obstacle. So it is basically on a safer side that our drone is free of like it will not get damaged. So at least by achieving level 3, we'll make sure that hardware is not getting damaged, but still there is a person involved maybe the involvement is becoming lesser and lesser, since a person will get involved only when the alarm is triggered. Other than that, pilot can do its own work, and then the drone can obviously fly automatically. So yes, if we come in level 4 now, it is high automation. So the drone can be controlled by a person, but it doesn't always need to be. It can fly itself full time under the right circumstances. So basically here now it is going to fly itself. So drone is expected to have a backup system so that if one system fails, it will still be operational, right? So its behavior depends upon a fixed built-in functionality or upon a fixed set of rules that dictate system behaviors. So here sense of the obstacle and avoidance of the obstacle both happens within UAV. So UAV knows now that there is an obstacle, and it also knows how to come out of that obstacle. Okay. Yeah, so it can obviously fly itself full time under the right circumstances. It can sense obstacle and avoid obstacle by changing direction or orientation. So it has that logic inside it. So if we say that it has its own brain, if there is some obstacle, how to react or what to react or where to go, it can sense that and navigate via it, and then obviously like it can move freely. So it doesn't need any pilot commands to move. Only in certain situations it needs. So basically, yeah, since it is a like high automation thing, applications are photography, filming. So now you might be seeing many of the drone shots have been filmed, and in the weddings nowadays, the drone shots are there. So here, pilot is just monitoring the drone, as in if something bad happens, then it will take control. But as since there is an obstacle, it will detect and then it will turn around the. So that's a great achievement. If we can achieve level 4 autonomy, that means we are in a very good shape currently. Yeah, so now level 5 means full automation. So the drone controls itself under all circumstances with no expectation of human intervention. This includes full-time automation of all flying tasks under any condition. So basically, in today's time, there are no such examples. Like there are no examples of such drones yet, and they are not currently in production. However, what they are expected to be able to do is use AI tool, artificial intelligence tools, to plan their flights. Like if I can say it in other words, it's like autonomous learning systems with the ability to modify routine defining behaviors. So like imagine if one day a level 5 drone is built and tasked with monitoring sharks on a coastline. Each day the drone monitors the coastline, but most often there are problems in a certain area of its flight path. This drone will in its next flight be able to use the acquired knowledge to plan a flight to monitor that area first. So like since there is a learning criteria which is happening, so like our we human, we also learn from our experiences. So drone is also learning from the experiences. It has the AI technology inbuilt inside it. So suppose it if the task is to find something, if it is not able to find at one place, so it can learn from their experiences and go to some other place, or learn from the data and go to some similar set of places where there is high probability of um, finding the particular thing. So this is full automation, but I cannot give you any examples. And there can be many use cases, many applications. Obviously, this is the thing which we want to achieve. But if it is still under the development phase, people are trying to build in that direction, trying to go in that particular direction. So basically, if we just summarize, there are 6 levels starting from 0 to 5. 0 no pilot, and 5 is we are still trying to achieve now. Here in level 5, drone does not need any monitoring. It can detect, navigate, learn from its past experiences because it is AI enabled. Okay, so like you can actually see that there are many there are many opportunities in this field currently. There are many advancements which are happening. So probably you guys can be part of it in future. Yeah, so let's jump to one more interesting facts about UAV. So maybe if you follow the news, you might have heard about Iran drone attacks in recently January 2023. So basically, several drone attacks has happened to a factory in Isfahan on the night of January 28, 29, 2023. And the suspicion is that the attacks were done by Israel. So it's still in the suspected form, but it has destroyed so many things in the defense space, which where the attacks has happened. So again, the coin has two faces. Like here where we are talking about the advantages of drone, there are many disadvantages which is taking place, but yeah, in geopolitics certain things keep on happening and it keep on going. But now with the drone it will be easier to attack on some different country. So still we have to maintain certain regulations, and there should be some tracking capability where we can track from where the drone is coming and what kind of drone it is. Okay. So yes, yeah. Here I am just showing you the different types of UAVs. One is multi-rotor drones. So you guys might be aware of it. Like you guys see quadcopter. Basically, it comes under multi-rotor drone because it has 4 rotors inside it. There are octacopters, there are hexacopters as well. So all of these comes under this category, multi-rotor drones. Then there is something called fixed wing drones. So the normal aircraft which we see, they are like fixed wing aircraft. So the drones are also made up in that particular sense. So it is like fixed wing where there is only one propeller and it works and behaves like that. The only disadvantage of a fixed wing drone is like it needs a runway for takeoff and landing. It cannot directly just hover, just like quadcopter. It can just take off and like you can see, it can just take off and land at the same time, at the same place. So it doesn't need much of a runway. Quadcopter doesn't need much of a runway, but fixed wing needs a runway. But if we compare both of these, since quadcopter has 4 motors and it is very small in size, so basically it the endurance of a quadcopter is very less, because with the motors, like with the batteries, we have to like turn on 4 motors. We have to control 4 motors by one battery. So endurance is very less for a quadcopter. And again, it depends on the size of the quadcopter and all. And but for the fixed wing, since there is only one prop, if we compare both of those are of the same size and all, obviously fixed wing is going to last long. So there is a huge endurance difference between both of these. And there is one single rotor drone, just like our helicopters. So inspiration has been taken from that. And yeah, so now one more model of drone or UAV, which is developed called VTOL, that is vertical takeoff and landing. So it is a combination of quadcopter or any rotor drone plus fixed wing. So here, as you can see, there are 4 rotors and there is one propeller, just like in fixed wing. Okay, so here while takeoff and landing, it uses those 4 motors like a quadcopter, and then for forward motion, it uses so it gets converted into fixed wing and it uses that propeller power, and then like it does its own motion. Okay, so it has both the functionalities. So here the main advantage is that the speed is obviously much higher in the fixed wing, and then there is again no need of any runway because takeoff and landing happens in the quadcopter mode. Any questions till now? Okay. Yeah. So just talk about a bit of physics, working principle of our UAV. So as we know, there are 4 forces: weight, lift, thrust, and drag. So weight is basically due to the mass of the drone. And if the weight is higher, it requires more power to lift the drone. Okay, so we have to kind of balance between all those 4 forces so that our UAV can work perfectly. Then the second force is lift. So it is basically due to pressure difference across the drone, and it is a vertical force acting on the drone. So this it depends on the speed, size, and shape of the propeller blade to decide like how much amount of lift force do you need. So yeah, the main thing is it is essential to lift the body against the gravity. So to create this force, all four propellers run at high speed to lift the drone. So during the takeoff, all props run at a very high speed so that we can generate enough lift force. We can generate enough lift force and then overpower this weight. Okay, and then the next force is thrust. So it is like it is helping our motion. So it is in the direction of motion. So however, like for drone dynamics, it is normal to the rotor plane rather than here in this direction. It is like normal to the rotor plane. And this is essential to move the drone in the desired direction at at equal speed. And then again, opposite to thrust, there is one more force called drag. So it is the opposite direction of motion due to air resistance. So since we are flying it in an environment, there will be resistance coming out of the air. So drag force is generated. So proper aerodynamical shape needs to be selected for reducing the drag force. So like basically weight is managed by mass of the aircraft. So we have to select a proper like optimized weight of the UAV according to the application. Then lift, we have to choose the motor vice versa according to the weight so that it can overcome the weight criteria and then we can lift off. And thrust is a thing which we have to increase always to overcome the drag. So drag should be minimal and thrust should be like not maximum, it should be sufficient enough to overcome the drag coming out of it. So for the drag we can actually select proper aerodynamical shape. So basically these four forces are there which always always present in an aerodynamical surface. Like for any aircraft, these are the basic four forces which will come into picture. So if we have to lift the aircraft, we have to overcome the weight criteria, and then um, uh, uh, um, for the drag we have a thrust. So if there is an engine aircraft, the engine generates a thrust. If there is a rotor aircraft, due to the propeller motion of the rotor, we get the thrust. So somehow we are getting all these four forces by the combination of each other. Yes. So yes, now if we talk about parts of a drone. So basically here you can see there is propeller, and where the propeller motors are connected, four props, motors. I am showing the parts of a quadcopter basically. Then there is an ESC called as electronic speed control. Then we have our flight controller into picture, and the camera. If the quadcopter has camera, then we'll get the first pilot view from the camera. And obviously all of these things are taking power from it. So we should be having a power distribution panel which can actually distribute the power among all these components. Like whatever power is needed to the ESC, it can actually give it to them, not too much of power or not too less of power. So it is basically controlling all the power. So this is power distribution panel. So all of these things will be connected to power distribution panel, and with the power distribution panel, flight controller will also be connected, and we'll be getting all the navigation things out of flight controller. Okay, and also one thing is that this frame should have sufficient strength to hold the propeller momentum and additional weight for the payload. So if we assume that this is a frame, so the strength should be sufficient to hold all of the payload things, and due to the rotation of propeller, what momentum is also going to generate. So the frame should have a sufficient capability to do it. Yeah, so propeller basically it has the load lifting capacity, and it also depends on the different shapes and sizes or number of props. Okay, so they are I am just showing you different kind of props. So it is called 2, 3, 4, 5, 6 by props. So it basically depends on the payload capacity, how much payload are we going to carry, or how much of the weight is of the total quadcopter. So according to that we choose the propeller. So 2 and 3 size are for smaller props, and 6 size is for the bigger prop. So long props are basically for heavy loads, and short props are to carry fewer loads, like to carry minimalistic loads. So whenever we are designing any quadcopter, we have to keep into account of all these things. So next component is motor. Yeah, so I think you guys have a decent background to understand about brush motor and brushless motor. So there can be two kind of motors, and that is up to us. That is up to the application of quadcopter to decide which motor to use. So for small size drones, they are brush motors, and for powerful or energy efficient drones, they are brushless motors. But they need ESC. ESC is electronic speed controller to control their speed. So as you can see here, first prop is connected with motor, and then motors are connected with ESC, and then the power is coming from power distribution board, and the signals are coming from flight controllers. So this is how connections are made for brushless motors. So ESC is needed for power for a prop to run or for a motor to run. So yeah, so here in ESC, it basically connects battery to motor for power supply, as I explained. And so there are some signals coming out of flight controller. So suppose there is a path which we have, which a UAV has to follow. Now flight controller will decide how much to turn, or how much like which are uh, we have to take a 2-degree turn in the pitch direction or roll direction. So it will give the command accordingly, but ESC will convert these signals to RPM, because motor only accept the RPM command, right? Motor can only turn with 1000 per minute. So ESC just takes in the command from flight controller, converts these signals into RPM, and therefore motor can run, and we can props can run, and we the quadcopter can take off. Okay. Yes, so next are payloads. We are keep saying about payloads and all. So basically it is the carrying capacity of the aircraft, and it is measured in terms of weight, kgs or pounds, etc. Because now when we talk about lift, it has to overcome the weight of the aircraft. So this weight will involve the full body of the quadcopter plus the payload which it is having. So the lift force is calculated by adding up all these forces. So it should be more than that to lift off. Okay, so according to that, we have to choose propellers and motors and all of these things. So payloads can be a stationary video camera, or a camera with gyro specialization, basically gimbal camera with like which has pan and tilt movement. Then high power radar it can have. And then if it is a delivering drone, it can have goods like whatever we has to deliver. So it depends on the use case, and again weapons, if there is a use case of that armed drones and all. So these things can be different payloads for a drone. It needs to be taken account while designing or while selecting a quadcopter motor. And then the main part is the flight controller. It is called as the brain of the UAV. It is doing all the calculations. So basically, if there are no sensors, then commands will be coming via joystick from the captain, that it is moving here, moving there, and all those things. If there are sensors, then it is taking sensor data into account. And then as an output, it controls motors for drone navigation. So it like basically the signals goes to ESC in brushless motors so that motors can navigate. So flight controller is doing all the things inside, doing all the calculation inside. If we have to follow a path, flight control will tell where to tilt, what should be the orientation. Well, getting the signals from all the sensors. And sensors are always GPS, accelerometer, gyroscope, magnetometer, compass, camera can also work as a sensor. So all those are examples of sensors. So yeah, coming to sensors. So basically, there is gyroscope, which determine orientation of the vehicle. And then there is GPS, determine position, basically latitude and longitude of the vehicle. So it is determining position of the vehicle with respect to the global position. Then we have accelerometer, which measures acceleration, and hence we get the velocity out of it, velocity of the aircraft. Then we have barometer to determine altitude. The altitude will be obviously mean sea level altitude, not the above ground level altitude. But since we have a baseline, so we can, if we want to calculate above ground altitude, we have to take a reading in the beginning. Suppose the reading is X. Suppose in Bangalore, normally our ground level is 700 meters, 700 to 800 meters. Okay, so we just took the reading at the very first instance that the altitude is 700 meters, and then as and when UAV is flying, we are getting one altitude, but that is mean sea level altitude. Okay, so suppose the altitude is saying it's 1000, but from the ground it's not 1000, it's 1000 minus 700, because our ground level is itself is 300 700 meters. So now from the ground UAV is 300, which is 1000 minus 700 meters. So UAV's above ground level height is 300 meters. So which again gets calculated using barometer or fusion data between barometer and GPS. And yes, talking about sensors, we have LiDAR, radar, and camera. For LiDAR and all for obstacle detection, camera for imaging. And there are other sensors like compass or magnetometer to find out the heading of the UAV or the orientation or position of the UAV. So here we are at one more interesting fact about the UAV. I hope you guys have heard about Boat Lab Dynamics. So I think it is a startup from IIT Delhi. So it has hosted second largest drone show of the world with 35 drones taking to the skies above Rashtrapati Bhavan during G20 summit. And you can actually see the symbol is made up by 3,500 drones. So, and since it was a second largest drone show involving 3,500 drones, so it was a like very big achievement or very big news for our company. So basically, Boat Lab Dynamics work in this direction where they host drone shows in different for government or for personal use cases and all. You can actually go to the website and check out, like it's really interesting the shows they have done. Okay. Yeah, so till now we have discussed about the UAV, totally UAV, like what parts are there inside a UAV, how it works, what is the working principle of the UAV. But now we'll discuss how it communicates via ground, how we get the information of position or orientation of the UAV from the ground. Because since we have discussed about the autonomy level, so there are 0, 1, 2, 3 autonomy where we need to have the information about drone in on the ground. It needs to be there so that pilot can take control whenever needed. So how the communication happens, that we are going to see. So yeah, this is UAS communication. So we have our unmanned vehicle. So basically this illustration shows the communication links between ground station. Here's the ground station, the airports or our air traffic controller, the satellite, and UAV. Okay, so UAV can communicate with the ground control station. We have a ground control station, so UAV will be having the transmitter, and via receiver we will receive the signal and will get to know the information about UAV in the GCS if it is in the line of sight. So basically, if the antenna can trace the UAV, if it is beyond line of sight, there is no way that we can get the information in ground control station, but there will be satellites which are tracking it. So for beyond line of sight, we control it via, or we get the information via satellites. And then there is air traffic controller communication services, which are also available, which these services are also communicating with the UAV. And it depends on what kind of UAVs are there. Okay, so for every UAV, there is no direct communication with ATC. But if UAV is for purpose under government used, they will be communicating via ATC communication services. And from ATC, there is again a ground connectivity. So if it is out of line of sight with the ground control station, we'll get the information from ATC. Okay, in all these ways, we are getting the information about UAV's position or UAV's, like whether UAV is fine or not. Like we are getting that information to ground control station. And if pilot needs to take control, he or she can take control again. So yeah, for the navigation system, basically there is a fusion happening between GPS, a global positioning system, and INS. INS is basically inertial navigation system. It provides the altitude information. So why INS is needed? Because we get altitude information from GPS, right? But there is a cache here. So while GPS services a seamless navigation with a cheap receiver, it may not receive a satellite signal by the obstacle or signal jamming, or if it is if UAV is inside some area inside the room and all, we normally do not get GPS signal. So like it might have happened with you also, like we are in a remote area, village area, or we are in a jungle kind of thing where we do not get GPS signal, but UAV is supposed to fly there, right? Like there is one of the application to fly inside a tree, like in for agricultural well-being. There's one application for that. So there INS plays a role. So it gets the information. So that is why we are saying that there's a fusion happening between GPS and INS. So whenever GPS data is available, the fusion will be there, which estimates the altitude and which will be far more correct altitude rather than only taking GPS altitude. And then if there is no GPS data, then INS will does its own calculation and give us the altitude value. Okay. And yes, so there will be a receiver in the aircraft as well to respond to the radar scanner emitting from the ground control station. And if the aircraft carries a camera, it will give the live feed to ground control station. So communication is happening both the ways. Aircraft is having a receiver as well to communicate, like to receive the data from ground control station. And again, ground control station is also having communicating with that. So it is a two-way communication. So there are two roles of ground control station. One is to control the drone. If autonomy level is not level 4, then obviously it has to control the drone. So here it's not like pilot is sitting with joystick and controlling the drone. So in autonomy level 3 and 4, we can give the commands using flight path, right? So these commands we give in ground control station. So it is basically controlling the drone. And the second thing is whatever data is coming out of UAV, it is processing that data, and then whatever like application wise, it is segregating that data and making use of it. So uh, these are the two main functionality of our ground control station. Talking about communication, obviously we have to talk about data link. Okay, so UAV to ground control station is the like there is a data link which connects both of them. It allows communication and enables the data transfer between a UAV and ground station. So since there is a two-way communication, there is an uplink and there is a downlink. So uplink is GCS to UAV. So it basically transfer flight path angle or real-time control commands. So like flight path, it can also change the flight path according to UAV behavior, or if like it sees that UAV battery is very less, then it can modify the flight path and ask UAV to land, right? So the commands are going from ground control station to UAV. This is uplink. And there's one more thing called downlink, where the commands are going from aircraft to ground control station. So here aircraft is sending its positional data and then camera feed. So this information is being received by our ground control station. Along with that, it sends its housekeeping data like fuel state, if it is a if it is run by fuel, otherwise battery percentage, how much battery is remaining. So that information, or engine temperature if there is an engine. So that information gets propagated via downlink. Okay. And in the previous slide, the same thing I have described that uh, there can be two types, or rather three types. Now there are three types. So one is line of sight. So this line of sight uses different frequency bands, and it needs two unit, drone and ground control station with antennas, and it allows point to point high speed communication. Okay. But if it is beyond line of sight, it comes under BLOS. So here in BLOS is uses satellites. So like links are usually made at microwave frequencies since we are using satellite data, and like the communication distances is greater than line of sight. And then there is one more thing called technical data communication. So like it is simultaneous communication and includes secure data transfer features among like other capabilities. So it requires lower bandwidth than other data links. So that is why people are preferring this nowadays. So it combines both of them, and it also requires lower bandwidth frequency. But like if I talk about one of the biggest challenge for UAV, it's like generally data links suffer from power attenuation or Doppler effect, which affects the spectral efficiency, and from many losses due to the channel characteristics. There are important, like basically there are many important requirements for this type of links, such as long distance and high speed. So that is why designing data links for UAV is much more challenging than designing other wireless link. So this is one of the biggest challenge to design a proper link. There should be a proper communication with all the systems. So yeah, so that is also an open area where most of the researches are taking place. Yeah, so till now, the paths have been discussed, and also about the communication, the ground communication, data link communication, and navigation has been covered. So any questions? I'll just wait for it. If you guys have any questions till now. Okay, great. Yeah, somebody wants to speak anything?
Ma'am, about this data link right now, there was ma'am talked about the issues that we are facing currently. That
Mhm.
is signal attenuation, and that is basically like we have difficulty communicating with UAVs at a long distance. So the advanced telecommunication industry of like having a
Mhm.
designation of telecommunication standards 5G, um, is does those like those standards, do they apply for UAVs and communication? I mean, like advancements in telecommunication, can that be used for this as well, or like would that help here?
Yes, that's a great question. Yeah, obviously. So now 5G is coming into picture. So now people are actually has started using it. So yes, it has already started to using 5G in the drone industry as well. So yeah, it will overcome these kind of challenges, but still there is no practical proof of it. It's still in the development phase. So yes, these communication protocol will actually help in the data link. Uh,
Yeah, ma'am. So like nobody has actually applied this, or like
No. People are actually doing it. There are many industries who are applying 5G. I'm not sure in India, but Israel specifically, they are using the technology. Um,
oh,
yeah.
okay, thank you.
Okay, no problem. Thanks for the question. Anybody else? Okay. Okay, I'll take it as a no. I'll just go ahead. Yeah. So while talking about it, let's come to India's drone industry. So actually, the highlight of the day is the government is planning to make India a global drone hub by 2030 and trying to expand its use in various sectors like health, defense, infrastructure, agriculture, etc. So, global drone hub by 2030, that means we have so much of work to do. And the great thing is there are so many startups are coming into this direction, in healthcare direction, defense, infrastructure direction. So those are actually going to help to achieve this particular target. And also, Finance Minister Nirmala Sitharaman announced the Drone Shakti scheme as part of the proposal of Union Budget 2022. So if you have watched the highlights of 2022, UAV was actually a highlight because Drone Shakti scheme have been launched, where it was proposed that like the investment should go on these kind of startups where drone applications are coming into picture. So you can see the results that Indian drone ecosystem is actually going higher now. So in 2020 to 2021, we had only $11.2 million business, but now in the year 2022 to 2023, we have actually achieved the target of 49.7 million, which is doubled of 2021 to 2022. So yeah, drone industry is going higher. So basically these numbers I have taken from Business Today, one of the articles of Business Today. So there they have explained like if it is double, then the growth is in a very major or good direction. And after announcing this proposal in 2022 and after announcement of global drone hub by 2030, so we are actually expanding in this industry. And they are, if we are expanding, then there should be many rules and regulations so that people don't misuse the opportunity, right? So that is why we have defined drone zones. These are basically permission protocol. So there are zones defined as red zone, yellow zone, and green zone. So in red zone, no drones can fly. In yellow zone, permission needs to be taken to fly the drone. And in green zone, we can fly the drone. So any hobbyist, if you want to do some experiments, or if you just want to fly a drone and check, you can actually go check out the green zone in your area and fly the drone. But now the question comes, how will you find out in which zone you are, or if you want to fly the UAV, whether this zone comes under green zone or not, or whether it comes under yellow zone. So for handling this issue, they have made, I'll just show you one link. Yeah, I think my screen sharing has stopped. Okay. Can you see my screen?
Yes, ma'am.
Okay, fine.
Yeah.
Okay, thank you. So there is a website made by our DGCA. So here, this is the map of the India, first of all, and I think you guys are sitting in Kochi, right? Currently.
Yes, ma'am.
Okay, so if I just type Kochi, so this is where you are. Here, you can actually check in which zone you are. So if I just select airport red, so basically the airport area within 5 kilometer range, it is declared as red zone. You cannot fly any UAV. So like you are very far from that area if you are sitting here. So these all are red zones. Here you cannot fly the UAV because these are basically airport areas. So within 5 kilometers of the radius, you cannot fly it because of ATC regulations, so that you don't interrupt the signals for the aircraft. So you cannot fly the drone in all those red areas. Okay. And now there is one more, there are two things defined. One is airport yellow 5 to 8 kilometers. The other one is airport yellow 8 to 12 kilometers. So basically, suppose there is an airport within 12 kilometers. So after 5 to 12 kilometers, if you want to fly the drone, you have to take permission because it comes under yellow zone now. Okay, so there's one red area, forget about flying here, but there is one yellow area. And if there is some, like if you really want to do certain experiments, you have to take special permission, obviously, which will be like given to people who are actually registered by a company or via some other means which are helping the government. So in the yellow zone, you can fly by taking the special permission. For example, this is one of the yellow zone. And yes, in the international boundary or India boundary, you cannot fly it. This is defined within 5 kilometers in range. So this whole line is 5 kilometers. So here in this boundary, which is touching all other states, you cannot fly. And there is one more thing defined as geo zone. So in the geo zones also you cannot fly. So basically geo zones are uh, these government organizations like ISRO, DRDO, or some army base camps. So where actually activities are happening which are not transferable. The data is not transferable. So here in those zones, you cannot fly. And if you look closely in Delhi, you can, like, it's very difficult to get a place to fly because the area, the density is very small. And most of the places, they are government, certain government entity sitting. So like if I zoom in, so here there are so many red zones in this particular area. There are so many red zones. So just a heads up, if you want to do any flying activity, just check where is your area, in which area you are coming in. If you are in the green area, so basically other than that, everything is green. This green area, green dots you can see, right? So those, just check if it is inside those green dots, you can fly, go and fly very easily. Okay, I'll just go to presentation mode now.
Um,
Yeah, my screen is visible in the presentation mode, right?
Yes, ma'am, it is. Yes.
Okay, fine. Thank you. Yeah, so like I described, red zone, then yellow zone, take permission fly, no permission required, green zone. So after 12 kilometers, so this line is up to 12 kilometer from the airport. And then there is one more zone called geo zones. Just make sure that you are not under geo zones to fly your drones. Okay. Yeah, so the main part, applications. So I keep on saying that there are so many applications of UAV currently. So one of the things is like you are seeing in the GIF, it's wind turbine cleaning. So this is just one example, but you can take it for a whole aircraft cleaning or whole aircraft maintenance and all. Okay, so you can just define the flight path. It should be having a sensor where it can detect where the turbine is and it can do its own duty. There is not much of a like you don't need to put so much of so much of coding inside or flight. You don't need to develop so much of flight controller. If you feed in right sensors, right data, right path, you the drone will do its duty. The only thing is you have to check on the endurance, whether endurance is sufficient enough for the whole cleaning purpose for a drone. The second application is remote sensing. So like currently drone technology has been used to get high resolution imagery data of remote areas like island, mountain tops or coastlines. So basically UAV technology bridges the gap between the airborne, spaceborne and ground-based remote sensing data. And like it is low cost, and obviously the main advantage is drone is very lightweight, so it actually supports the quality observation with like high spatial resolution. And also the remote sensing capabilities of UAVs can also support in disease detection, water quality monitoring, drought monitoring, oil leaks, like you name it. There are many advantages. And then geological disaster survey, it can help in that, terrain survey, forest mapping, and again crop monitoring in agriculture. So like this can be used for crowdsource mapping, like creation of 3D environment. Like you just send a drone, it will just create a map of the place. These has become a very active part of these like cartography technology. And drones are also affordable nowadays, so it helps in provide latest data that can fit land planning budget without like relying on outdated mapping sources. So we get real time data, we get what the situation is currently without believing much on the past available data. So that is a very practical advantage of drone technology currently. Yeah, and then like at your places also, you might have seen the line damages, the power line damages, damage which happens during bad weather and all those conditions. So normally a human goes and fix those power lines, but here drone can actually go monitor where the problem has happened. It can provide the data, and then since it is taking the images and all, we on the ground sitting on looking at the images, we can find out where the problem is, what the problem is, and what things need to be done. And if the drone is capable enough, it can actually go and fix all these lines. So that also come along with the technological advancement. Like maybe by 2030 we are committing that deadline. uh, yes, and then the other one is UAV assistance on highway. So basically, if certain accident happens, UAV can directly take the location. First of all, it has its own technology. It can detect that accident has happened, so nobody has to come and inform that accident is there. Accident has taken place. It can detect, take the image, send it to ambulance and police, send the data where the accident has happened, basically the latitude and longitude information of the place, and then police and ambulance can quickly respond, come to the place and help the needy guy. But for that, surveillance needs to be taken place. So maybe for the beginning, we can actually start surveillance in the areas where, which are like accident prone areas. Here we can like particularly surveillance in that area. If something happens, just inform it, and the obviously things will be much faster to go around. Yeah, we are talking about surveillance, and that is one of the like biggest thing which we have achieved using drones. So many countries are doing it for military missions and all. And UAV can provide these services by sensing an automatic alert with minimal manual efforts. So there is no human intervention needed. UAV can sense it and then surveillance it, send out the data to ground control station, and the person there can actually verify and check with whether there is a problem or not. So like in the border, we see India Pak border and all, people have, so basically in they are in the extreme condition in Ladakh, and also our soldiers has to come out and check whether there is some activity happening. But now they do not need to come out in the harsh environment during the cold night. Drone can do their works, and drone is actually sending them the data. And if it is more advanced, it is actually giving a signal if certain activities are happening. So in military use, this will be a like very big application. And yes, disaster management like terrorist attacks, tsunami, floods, or they are like, if there is some delivery, we need to deliver some food items and all in these areas where human can actually not go. UAV can go and um, it can deliver whatever is needed. So help out the people. And search and rescue, yes. So it, by using that, we can actually save a lot of manpower and resources. So like you might have heard in the Himalaya region and all, after death zone there are so many people, and then during the avalanche also, like if avalanche comes in, nobody knows where are the people and all, it's very difficult to even find out the bodies. So drone can actually go to that area if it has the capability to fly to that particular altitude, can go and actually detect where the person is, rather than a person going and searching for the people. Drone can go detect it, send out the location, then the team can come in, pitch in, and then do whatever is needed the next. So yeah, in the search and rescue mission, drone can be useful. And again, construction and infrastructure inspection. So if there are certain buildings which are under construction, so drone can go and monitor all those building, and it can actually contribute from start to finish and send out the quality progress report. We can just train the drone that you have to check these things, and if there is some anomaly, just contact us, send us an alarm. So it will actually go inspect, and if there is some anomaly, it will do the same thing, it will send us the alarm. So basically we are making that quality is also not compromised using drone. So we'll make sure that quality is good, the construction is good, construction is going as expected. And yeah, it is providing all the imagery, videos, 3D mapping, all those things. And then agriculture. So agriculture has a very big use case. So first thing is collecting data from ground sensors. By collecting data, we can actually find out how is the water quality, and then different soil properties, moisture, and all those things. So here we are just showing that a drone went and collected all the data, and then after understanding it, it found out that this particular land area is not good for this crops. So and then these are the areas where we will get the maximum benefits. So we can actually use this information and only for one particular, only use these areas rather than going into these particular areas. Okay, so it is basically enhancing profitability and productivity in farming systems. And yes, one more application is automated forest restoration. We keep hearing about it. So basically, drones can go and capture all these forest areas, and it can divide it. Like here, there are different labels, so it can label it in different domains. And so basically, it can what restoration needs to be done where. So the process can be pretty fast. So it can actually monitor the climate, ecosystem composition, and like functions of forest and all those things. And since the cameras will be high resolution, it can take in zoom in photos, which will be very easy to analyze by the experts. So they can analyze it, and then they can work way faster than they used to work for forest restoration. So these are some of the applications. Obviously, I cannot cover all of these because there are many, as I keep on saying, like drones are the future. Like I have just touched upon one particular domain, but other than that, you can find out many applications of it. And even you can make your own application and start developing something out of it. So yeah, so I'll just touch upon, like briefly touch upon my projects which I have done by myself, like in the due course of time. So one was swarm of quadcopter. So this video I have taken from internet. So just to show you how a swarm works. Basically, these all quadcopters are communicating with each other so that they don't get hit. And there is one particular path which they have to follow. So there is a target location where they have to go. So they are just randomize themselves, and then they are analyzing where each drone is, and then trying to go to that target. And here there is one obstacle. So there were 12 drones before. Now they actually saw it and analyzed that we all cannot go together. They were coming in the queue of 4-4. They analyzed they all cannot go together. So they automatically maintain this much is the distance. So at least 2 drones can go. So they have like made a line of two drones and came back in the same position again. So that is how they are like overcoming the obstacle as well by their own intelligence. There is no pilot involved. So basically, in the swarm, there is one follower, and there is one lead, which is called as swarm lead, or there can be multiple leads, and there will be followers, squad followers. So basically, it is a two-way communication between master and slave. So master is the swarm lead, and slave is the followers. Um, and it is being used in warfare and terrorist operations, search and rescue operations, and all. And basically, if since in one of the videos it was inside, right? So there's a high probability that the data is not GPS data is not proper. So here we have to use estimation algorithm for inside environment. So we do not need to worry if there is no GPS data. The drone can work in the GPS denied environment using some calculations. And then there are onboard sensors and different processors for control, for planning, for state estimation and all. And if there is a LiDAR, LiDAR is basically light detection and ranging. So it is a remote sensing method that uses light in the form of a pulsed laser to measure ranges to Earth. So like the distances it measures from the Earth. So if there are LiDARs, then it can detect the obstacles as well. So just for example, drone swarms can identify and attack the enemy defenses in an autonomous way. They can search for enemy submarines in the ocean by incorporating infrared sensors. They can assist rescue teams by obtaining a real-time map of the advance of fire. So in all the like normal room inside the fire and inside the ocean, they can go and give the information. Swarm. So one of the application which we did was in disaster relief. So for an example, there is some disaster somewhere, and drone has to go and provide and help or provide some goods like goods to the people. So since I have mentioned that drones endurance is less, what we did is like we used to send a fixed wing to get to know about the latitude and longitude information where the disaster has happened. So it will just go and it will be having its own camera. On its intelligence, it will just make a decision where the disaster has happened. Okay, and the quads do not have the cameras inside in this particular scenario. It just collects a lat log information and gives the information to the master of the swarm. Okay, and then the master will now assign the positions to all these followers there. So there can be multiple masters. I'm just taking one group of master and slave, or one group of master and follower. So master has collected the information and then assigned the position to all the followers. And here it is a two-way communication. So from fixed wing to master, there was a one-way communication because it just needed to take the information from the fixed wing. Fixed wing doesn't need to know where you are currently. It just gave the information. And here it is a two-way communication because follower has to tell where are we to the master, because master is the one who is deciding where the other UAV will go. Okay, so once the position is assigned, they all will reach to that particular destination and then provide the goods or provide help which was needed. So there will be hundreds of drones which are flying all together. So that is why, to like in a class, there is a monitor or there is a teacher which maintains the class. Otherwise, everybody will be randomized. So rather than fixed wing giving the information to all the quads, it will just give the information to the masters. and then master will propagate the information. So it's just making the work easier where multiple drones are required. That is why like the swarm algorithm is a is very useful when multiple drones are taking place, the or multiple drones are working together. So just decide a master or multiple masters and decide a set of followers under it, and then you can do or you can make use of it in any of the applications. So that was a case of a disaster relief application. So other than that, there was one more functionality on which I worked on. It is called target tracking functionality. So here, the drone will just capture the image, detect. So we will be providing the data by image processing, or there will be a target tracking functionality where we will be saying that we want to track this particular thing. Just take the laser pointer. Yeah. So suppose here we have taken that we want to trace this bus, okay, or this truck. So all other vehicles, it is marking red saying I don't want to track it, but I want to track this particular vehicle. So this tracking thing has been defined by target tracking functionality, that you have to track this. So now the signal is gone to the other sensor or the camera or gimbal that okay, I have to track it. So there can be two things, that target is moving or target is stationary. If the target is stationary, drone will start hovering around it to track it. If target starts moving, then drone has to move along with it. It has to follow that speed. And sometimes it can happen that it has to zoom in to look into the target or to identify the target. So the main challenge was during the zooming, we have to stabilize the drone because camera is zoomed in and then the stability will come into the picture. So we were able to achieve till 6x zoom level. So till 6x zoom, if the drone zooms in, we can maintain the stability. Even we have gone till 12x. It was a bit unstable, but it was like it can work sufficiently well. So yeah, so after doing gimbal stabilization, after applying Kalman filter algorithm, we were able to achieve it. So that was one of the application for our fixed wing. Where, so this is an application of a surveillance. Suppose if we want to for one particular area, for one particular vehicle, or even for crops, we have to do some surveillance. We can use this particular functionality. And if it is a moving vehicle, we have to use the gimbal so that our camera is also moving along with it. Yeah, just some conclusory remarks. Basically, and yeah, here this is Rustam 2, our Indian drone. So basically, unmanned aerial vehicles are an exciting field to work on, and like now there are so many new discoveries are happening in the aviation. So yes, it keeps on growing, I believe. And over the years, UAVs will become a significant component of military, civil, and perhaps even commercial aviation. We are talking about air taxis right now. So there is so much of capabilities currently. And as of now, there are total 131 Indian drone companies which exist. Some of these are just mentioned here. So you can like these companies are doing extraordinary work. You can check them out on their website, probably. Yes. And yeah, I think that's it from my side. Thanks a lot. Thank you for the patience to listen to me. I hope things are clear to you, and I am open for questions, answer session if you have any. Hello.
Yes, ma'am.
Yes.
Participants can please use the chat to ask the queries.
Okay. I think everything is clear to everybody.
Ma'am, I think there are no more questions, no questions left. Thank you so much, ma'am. It was a really thought-provoking and insightful session, and it has left us with new perspectives and a deeper understanding about UAS autonomy. And as a small token of gratitude from our part, we would like to present a memento.
Thank you. Thank you so much. Thanks for this opportunity.
Thank you, ma'am. To mark this occasion, let's capture an online group photo. So I request everyone to turn on their cameras.
Sure.
I hope it's done. Thank you so much, ma'am, for joining with us here today. Thank you so much.
Thank you.